Hello everyone, I am Professor Aher. In this video, we are going to see one of the root of the equation, that is a bisection method, and we are going to solve numerical by iteration criteria. That is a bisection method. Now, what is actually the bisection method? Bisection method is one of the bracketing method for finding the root of the equations. Important point, that is the root of equation. Now, if you see the curve, that is f of x, which is placed in x and y axis, now curve which intersect the x axis, that point is nothing but the root of the equation. So in this, first we have to solve analytical problem and create the flow chart for the process. Solve. Determine using bisection method a root of the equation cos x minus 1.3x equal to 0 using 5 iterations. So solution for that numerical, starting with first is a function, that is a cos x minus 1.3x equal to 0, and again number of iterations are given, that is 5. Initial cases that you have to assume x1 equal to 0.5 and x2 equal to 1. Next step is to find out the functions f of x1 and f of x2 for verifying initial guesses are right or wrong. So answer we got, first is a positive one, f of x1 is 0.22 and f of x2 is minus 0.75, which is negative. Now you have to see the condition, that is a condition of condition for convergence is f of x1 into f of x2 should be less than 0. So put the value of f of x1 and f of x2, and it should be less than 0. As they are less than 0, so initial guesses that whatever we have considered, so that is a correct. Okay. Next step is to go for first iteration. For that, x1 equal to 0.5 and x2 equal to 1. So calculate the new root, that is x3, which is equal to x1 plus x2 divided by 2, which is a bisection method formula, and we'll get 0.75. x3 is now equal to 0.75, and find out the function for that, that is f of 0.75. then function whatever we are getting, that is minus 0.2433, which is negative. Next step is to replace x1 or x2 by x3, and for that condition is, that is a sign, whether it is positive or negative. Now first of all, for replacing f of x1, that we have got positive, and f of x2 that was negative, and f of x3 is also negative. So replace x2 by x3, as both are have same sign. Next, now new roots that are x1 equal to 0.5 and x2 equal to 0.75. Next step is go for second iteration, x2 equal to 0.5, x2 equal to new root, that is 0.75. Find out x3, that is a x1 plus x2 divided by 2, bisection formula is there. Then again find out the function of x3, and again see the sign, and with the help of sign replace x2 by x3. Follow the same procedure till iteration 5. Now if you tabulate all the 5 iterations result in the above format, at the 5th iterations, that is a 0.6093, which is a required root of the equation. Next we'll see the algorithm of the bisection method and flowchart of bisection method. So first there is start of the program. Next is the define the function as f of x. After that you have to enter the value of initial guesses, that is x1 and x2, and also the number of iterations. Next put the value of x1 and x2 in the equation by using the command, that is f y1 equal to f of x1 and y2 equal to f of x2. Next step is to check for y1 into y2 whether they are greater than 0. If yes, then we have to again guess the new values of x1 and x2. Next step is to take the number of iterations. For that, first iteration, that is n equal to 1, that we have to calculate the value of approximate root, and using the bisection formula, that is x3 equal to x1 plus x2. Okay, so this step will be performed continuously. For that for loop you use up till the n iteration, and at last we have to print the root x3 and the program will be end. Thank you. Thanks for watching.